Okay, let's start section 1.8, and we're going to look at some other types of equations that we can learn to solve. To solve radical equations, we need to use a little property that says if two things or two items are equal to one another, then they're still going to be equal if we raise them to identical powers. So if a equals b, then a to the n must equal b to the n. And what this allows us to do is it allows us to isolate radicals and problems with rational exponents. It allows us to eliminate the radicals and the exponents. The key to doing this is to make sure that you've isolated the radical if possible. Sometimes there are some problems where you can't isolate the radical. I didn't add any of these, but some of those can take forever. So I'm just going to give you the basics on these. Let's take a look at number 1. Here you have the square root of 3x plus 1 equal to x minus 1. Now in this problem you have a square root, and that square root is all by itself on the equal sign. And that's important because it's much easier to solve a square root problem like this if you've got the square root isolated by itself. Because all I have to do now to eliminate a square root, all I have to do is square it. So since I have this property up here that says since those two things are equal, then their squares will be equal. I mean, that's what it says, right? Any power of n. So I'm just going to square both of these. So if I square this side, and the reason I'm using a 2 here for the power instead of a 3 or 4, because the 2 will eliminate the square root. So if I raise the square root to the second power, it just eliminates that square root. Now, where you have to be careful is you're squaring a binomial. And when you square a binomial, you get 3 terms. So make sure that you realize you're going to get 3 terms. You're going to get the first term squared. You're going to get twice the product of the middle term. Actually, in this case, you're going to get minus twice the product of the middle term. The product of x and 1, rather. And then you're going to get the second term is going to be squared, and that's going to give you a plus 1. So you might want to review how to square a binomial. You can always do it the long way. Just do x minus 1 times x minus 1 and FOIL. But it's for me it's quicker because I know the formula for squaring a binomial. All right, now that we have it in this form, if we notice here we have x squared. So we're going to get a quadratic equation out of this, and all I have to do is let's take these two terms here, the 3x and the plus 1, and let's move them to the other side of the equal sign. So if I move the 3x over, I'm going to get a minus 3x, and if I move the 1 over, I'm going to get a minus 1, and then I can combine like terms over here with these other two terms, like minus 2x minus 3x gives me minus 5x. And then, of course, plus 1 and minus 1, they're just going to cancel out. So I'm just going to get x squared minus 5x. Now, so now I have a quadratic equation, and we talked about how to solve these in the last chapter or section. But this one, I don't need to do anything fancy to solve this one. I have a common factor of x in these two terms. So I'm just going to factor an x out of those two terms, and when I factor an x out of here I get x, and when I factor an x out of minus 5x I get minus 5. And so basically I get these two equations, x equals 0 and x minus 5 equals 0. Okay, now x minus 5 equals 0, that's easy to solve. That's just x equals 5. And of course x equals 0 gives me x equals 0. But here's the catch. With these radical equations, you always have to check your answers because you get what's called extraneous roots, and that's just a fancy word for saying an answer that doesn't work. So if you plug 0 in, let's go up here and plug 0. If you plug 0 in here and plug it in here, well, the left side's going to be square root of 1, which is 1. But the right side's going to be 0 minus 1, which is negative 1. So that 0 is not going to work. So you got to toss that critter, get rid of it. Now the x minus 5 equals 0, x equals 5. So let's see, if let's get rid of this little doodad here. If I put 5 in here, 3 times 5 is 15. 15 plus 1 is 16, and the square root of 16 is 4. So the left-hand side would be 4, and over here 5 minus 1 would be 4. So yeah, 5 works, but the 0 does not work. So be very careful there. Now, here I have a rational exponent. I have x minus 1 raised to the 3/2 power. Now, there's a little trick, and I actually could give you just a quick little theorem here. If I had, let's see, how could I show you this? All right, let me just say it this way. If you had a raised to the m over n power, and you wanted to get rid of that m over n, if you raise it to the reciprocal of that, n over m, well, guess what that would give you? That would just give you a. Okay, and the reason is because remember, when you raise a power to a power, you multiply exponents, and if you multiply m over n by its reciprocal, n over m, they just cancel each other out, and you just get a to the 1. So if I want to eliminate a fractional exponent, then all I have to do is raise this expression to the reciprocal power. So in other words, to eliminate this 3/2 power, if I take all of this x minus 1 that's raised to the 3/2, and if I raise it to the 2/3, then the 3/2 times the 2/3 basically cancel each other out, and I get x minus 1 to the 1st power, which is the same as just x minus 1. Now, of course, I can't do this I can't raise this side to the 2/3 without raising this side to the 2/3. So I have to raise that side to the 2/3 as well. But now let's remember, what does it mean when we raise 8 to the 2/3? Remember, when you raise a number to a fraction power, the denominator is the root and the numerator is the power. So this is like the 3rd root of 8 quantity squared. So I take the 3rd root of 8, which is 2, and then I square it and get 4. So if you want me to, I can write that right there. That's actually 2 squared. So that's how I got 4. So that's 4. So now I have x minus 1 equals 4, and then I just add 1, and I get x equals 5. And you can check it. It works, but you still should check it just to make sure. Okay, let's try this. Now, look at number 3. In this one, I have a cube root. Okay, a cube root. Now, the first thing someone might try here is to do this. Is to cube, both sides. But, let me tell you something. You saw up there how difficult it was for me to square a binomial. Well, how difficult do you think it would be for me to cube a binomial? It's not near as easy as you think. So no, we don't want to try to eliminate the radical yet. What we want to do is we want to add 1 to both sides. Let's get rid of this number that's outside the radical. So let's just add 1 to both sides. Let me get rid of this little guy here. Okay, so now if I add 1, these will cancel, and then 1 plus 1 is 2. So now I'll have nothing over here but just the cube root. So I have this cube root isolated now, and that makes my life a lot easier because now I can just cube this single term. So I'll cube the left side, and then I'll cube the right side. And of course, again, the reason I'm cubing it is so that it will eliminate the cube root. So cube root cubed just gives me what's in the radical, 2x minus 3, and 2 cubed is 8. And then once you get to that point, you should be able to solve it easily. Just add 3, and 2x is 11, then divide by 2, and you get x is 11/2. And again, make sure you check it. Okay, let's do one more of these, and then we'll probably shut this video down on that. Okay, so here we have x plus 1 to the 4/3 minus 3. And again, I don't want to try to eliminate this rational exponent until I isolate this. I want to try, if any way I can, I want to isolate this. So what I'm going to do is I'm going to add 3 to both sides. And then obviously that cancels the 3, and 13 plus 3 is 16. So now I have 16 over here, and now I have this isolated. Now remember that property I told you? This is raised to the 4/3 power. So I want to raise all of this to the 3/4 power, the reciprocal. So I'll raise this to the 3/4 power, and then what will happen is when I raise it to the 3/4 power, these two powers cancel out, and I just get x plus 1 to the 1st power. But I also have to raise this to the 3/4 power. Now, notice something here. This is really nasty. Notice I put plus or minus. The reason I put plus or minus is because I'm applying an even root. When I take 3/4, when I apply the 3/4 power, I'm applying an even root. It's like when you take the square root, when you apply a square root, you know, the answer is plus or minus. So I'll show you at the end here that I get two answers that work. So anyway, it's plus or minus because I applied an even root. Okay, so now this is the 4th root of 16. Now you know the 4th root of 16 is 2, right? Well, if you don't, you do now. So plus or minus 2. So I have plus or minus 2, and then I have to cube that. Okay? And that's what I'm showing you down here. So when I cube 2, I get plus 8. When I cube negative 2, I get minus 8. So you actually got two answers here. You got negative 1 plus 8, which is 7, and you've got negative 1 minus 8, which is negative 9. Now let's check that real quick. Let me set it up first. Okay, let me show you what I did here. If I check 7, then basically I get 7 plus 1 in here. So what I would get is I would get 8 to the 4/3 minus 3 equals 13. Well, 8 to the 4/3, that would be the cube root of 8, which is 2, and then raised to the 4th power. So it'd be 2 to the 4th minus 3. And then 2 to the 4th power is 16. And 16 minus 3 is indeed 13. Now, look down here. What if I plug negative 9 in? Well, negative 9 plus 1 would be negative 8. So I'd have negative 8 all to the 4/3. Well, the cube root of negative 8 is negative 2, right? But when you raise negative 2 to the 4th power, it's still positive 16. So there's actually two numbers when raised to the 4th power that give me 16, and that's 2 and negative 2. So that's why there's two answers here on this problem. And so the two answers are 7 and negative 9. And again, the key is always isolating the expression where you're trying to either eliminate the radical or eliminate the rational exponent. And I'm going to talk to you in the next video about some problems where you have to use what's called a U substitution in order to get solve the equations.